Okay, let's just jump right in. If you're running any kind of industrial dust collection system, picking a filter is, well, it's way more than just a simple maintenance task. Honestly, it's a critical business decision, one that can seriously impact your bottom line, your efficiency, and even your safety. So we're going to break down exactly how to get it right.
And the stakes here, they are incredibly high. I mean, yeah, the cost of the filters themselves can run into the thousands for sure, but that's just the tip of the iceberg. The real killer, the thing you have to worry about, is production downtime. An unexpected shutdown because a filter failed, that can cost a company way more than the filters ever will.
That's the million-dollar question, isn't it? This isn't about just grabbing whatever was in there before and swapping it out. It's about making a smart, data-driven decision that's going to optimize your entire operation. And that's exactly what we're going to do here. Give you a clear framework for making that perfect choice.
To do this, we're going to use something called the 5-point litmus test. Think of it as a simple but really powerful framework that helps you move beyond just guesswork. It's designed to guide you straight to the ideal filter material for your specific job. This is going to be your foundation for getting that perfect match. So let's break down these 5 critical factors. First up, we've got operating temperature, because too much heat will just degrade those filter fibers over time and slash their lifespan. Then there's chemical exposure. Are you dealing with acids or alkalis? Stuff that can literally eat away at the filter material. Next is mechanical stress. You can think of this like your laundry, right? A harsh, frequent cleaning cycle wears out the fabric way faster. Also, the particle characteristics themselves. Is your dust super fine? Is it sticky? Or is it abrasive? Abrasive dust acts just like sandpaper, while sticky dust can literally choke the filter. And finally, moisture level. Humidity can cause dust to cake on, or even worse, it can trigger chemical reactions that just destroy the filter from the inside out. And you want to see how much this matters? Get this, the data shows that just by operating 50 degrees below a material's max temperature, you can extend its life by up to 50%. But on the flip side, if you get the chemical environment wrong, let's say a pH level below 4 or above 10, you can cut its expected service life in half. So yeah, it's pretty clear. The details really matter.
Okay, so with that framework in our back pocket, let's look at the actual materials, starting with the workhorses. For a lot of the common moderate-duty jobs out there, these standard felts are going to give you the absolute best balance of performance and cost.
This really breaks it down into a simple decision. So if you're dealing with dry conditions under 275 degrees, think woodworking or food processing, then polyester is your go-to. If your process is highly acidic or wet but it's running cooler, under 200 degrees, then polypropylene is built for exactly that. And if high humidity is your main enemy, acrylic is a fantastic choice.
But you know, what happens when those standard materials just can't take the heat or the chemical assault? Well, that's when you have to step up to a whole different category of more robust, specialized materials. These are designed specifically for the toughest industrial environments you can imagine.
So Aramid, that's your intermediate high-temp solution. It's perfect for places like cement plants. PPS steps it up a notch, handling both heat and chemicals, which makes it ideal for coal-fired power plants. P84 is for the really extreme stuff, like waste incineration. And then you've got PTFE. That's the premium option, the whole shebang, combining top-tier heat and chemical resistance for the longest possible service life.
Okay, so we've covered the base materials, but sometimes the problem isn't the material itself, but a really specific, nagging operational headache. So now we're going to look at some advanced treatments and designs that act like targeted problem solvers.
And this is a perfect example of one of those problems. This is a classic filter failure called blinding. It's where sticky or moist dust just cakes onto the filter and it absolutely refuses to release during the cleaning pulse. So what happens? The airflow gets choked, your fans have to work way harder, and your energy costs just skyrocket.
Now, the key takeaway here, and this can be a real aha moment for a lot of operators, is that you don't always need a whole new filter material. Sometimes you just need the right treatment. For that blinding problem we just saw, a glazed surface or an oil repellent treatment works wonders. If abrasion is chewing up your filters, a heavy silicone coating can protect those fibers. And for safety, with sparks or an explosion risk, you can specify media with flame-retardant properties or even a stainless steel blend to dissipate static safely.
These treatments are powerful tools for sure, but for a lot of older baghouses, the single biggest leap in performance you can make doesn't come from a new material or coating. It comes from a fundamental change in the filter design itself, switching to a pleated bag. This is a total game changer.
So a pleated bag basically combines the housing of your traditional baghouse with the high-efficiency performance of a modern cartridge collector. What does that mean for you? You immediately get way more filter area in the exact same footprint, which right away leads to lower energy use. They're also more durable, and this is a big one, they are so much quicker and easier to change out, which saves a huge amount of time and hassle on maintenance.
And the performance data is just stunning. In a head-to-head test, pleated bags had a 62% lower pressure drop. Now, pressure drop is just a measure of resistance. It's how hard your fan has to work. A drop this big translates directly to massive energy savings.
They also needed 87% fewer cleaning pulses. What does that mean? It means a lot less wear and tear on your filters and a huge drop in your compressed air consumption.
And for compliance and air quality, a 94% reduction in emissions. I mean, that is just a staggering improvement, especially for meeting today's strict standards.
So, after all of this, what's the ultimate takeaway? It's actually pretty simple. The longest-lasting, most cost-effective filter isn't always the most expensive one, and it's not always the one with the highest temperature rating. It's the one that is perfectly matched to the unique conditions of its job.
At the end of the day, your entire dust collection system is only as good as the filters you put inside it. Applying this framework can save you money, it can slash your downtime, and it can create a much safer environment. So the question to ask yourself is, what's inside your collector? And is it truly the right choice for the job?